Hey guys, welcome. This is Mohammed Alamin Sisi, and I would like to welcome you today to another series of my series of video on CCNA. Today we'll be looking at frame relay. Okay, and here is a topology. This is the design and network, complete network design on frame relay, and we have LAN. Is a local LAN, a local area network, and here is another local area network, here another local area network, as well as this one. So we have like 4. Okay, so here we have the frame relay switch and the routers that are connected to the frame relay. Okay, here you can see the point-to-point links. Okay, this one like saying 192.168.0.1 is telling the router 1 to router 2. Okay, the link that connects this router to this one. Okay, and you have 1.1 192.168.1.1 tells you that R1 to R3, and this it means here to here, and you have R1 to R4. This one is supposed to be R1 to R4. Okay, we connect this one to this one. Okay, and after which we'll have a number of point-to-point connections as well. This one is a point-to-point, you can see /30, and mind you, all of this one are /30, which means they are point-to-point connections. Okay, but one thing I would like to emphasize here, and I just want you to understand this topology. Look at it keenly, look at the structure, the design of this topology here. Okay, then we are going to do the same topology, but why here? Okay, let me just, you can see we've done this, I've done this one, I'm sorry. Here I have a DNS server, then all of these LANs, I did a DHCP configuration, which means the router is able to list IP addresses to each of these end devices automatically. Okay, I do not need to do any manual assignment of IP addresses. Okay, except on the DNS server. If you open the DNS server here, then you come to IP configuration, you can see that it's static. Okay, the reason why is because this is a service. Okay, so when you're doing for service, it's advisable in real world for you to do static assignment. Okay, the reason being, if there is any problem with the router in the network, then the router failed to assign, okay, excuse me, IP addresses, okay, or the end devices lose their IP addresses, then the physically assigned, so the statically assigned addresses will not be lost. Okay, unlike the dynamically assigned. Okay, once there is problem with the router, the dynamically assigned IP address will get lost. Okay, so because of that, it is advisable that on service devices, you do static assignment. Okay, it's also because of with dynamic assignment, you have list period. Okay, after that period, the IP address will get lost. Then the router will reassign IP address to these devices, which might be a different IP address. So because of all that, supposing you have like let me just over here. Now we have, let me over the mouse here. Okay, we'll have 192.168.10.11 here. So if this address gets lost, then the router reassign another IP address, which might be like 10.12 to this. Then if you have a service, okay, if this is a host device, okay, like it's a web host, okay, web server for instance, okay, or we'll take this one, the DNS server, okay, which is 10.10. then if it is automatically assigned, okay, by the router, then when that address gets lost, maybe the reassignment, it will be like 10.11. then if someone is trying to log in, okay, someone is trying to reach this server, I mean on 10.10, 192.168.10.10, then it will be unreachable, okay, because the address has what changed over the time. Okay, so because of that, we're doing static assignment on services. Okay, it's not that much important on other end devices, because when the address gets changed, then I mean someone will just, I mean you don't have any urgent need for end devices like the PCs and the laptops. Okay, somehow they are personal devices. Okay, unlike this one where you have a number of users, even for remote access, you know, all of these things, so they need static assignment. Okay, so that's what we're going to look at. And also one thing I want you to note here, this packet tracer 7.0, you can see here. Okay, let me maximize again, sorry. Okay, here 7.0. okay, and this is what happened with this application. Okay, normally after 10 devices have been added, okay, you will see that the 11, any other device, in fact any other device after the 10th one expired, PC and laptop, after 10 personal computers have been added to this application, the 12 have been connected, to be specific, have been connected. The 11th and any other one will not be connected, will be automatically disabled. This is what you are seeing here, these red lines. Okay, they are really connected, they should have their IP address, but automatically these are blocked. Okay, so this is what happened because I connected 3. This is my LAN 1. I connected 3 PCs. Don't count these servers. I can add servers, no problem, they will still function. But this one PCs, we have 3 here, include the laptop. I have another 3 sets here, another 3 here, that another 4 here. This is 10. Okay, so after this one, this is the last LAN and the last area I did the connections. So you can see that only the server get connected, but all the PCs and laptop are not connected. So this is what really happened with me in real life. Okay, this is what happened with me with this this is a bad experience I have got with this packet tracer 7.0. okay, so that is it. This is the same topology we want to design here. We are coming to do this one from scratch to end, and we are going to do that with packet tracer, I'm sorry, 5.3.1. okay, that is the version we're going to do, because I mean with it, I mean I can add as much PCs and laptop as I wish, okay, without having any auto block or auto stop devices. So therefore we're going to use that one. Okay, so here we'll have a frame relay cloud. We'll have a cloud where we'll configure our DLCIs. Okay, and we've assigned here on the routers, and here also we're using our RIP protocol. Okay, we are using RIP protocol version 2. okay, so that is it. Now let me just show you. If you want to access, like let me come from this PC and let me come to this web browser. Okay, if I type now www.cisco.com, okay, that will open the site which resides in the DNS server. So if I do this one, that is it. Okay, the link is open. Okay, so I can close this one, and let me just over the mouse here. You can see the IP address 192.168.12.5/24. okay, and you can see gateway of 12.1. you can see our DNS server, and the DNS server is the same cut across in all LAN networks. Okay, come here again, you can see the DNS server here as 10.1. okay, you come to this one here. Okay, you can see DNS server as 10.1. I'm sorry, 10.10. okay, so that is it. So this is the address of this server. Okay, you can see here 10.1. okay, 24. Now what I did here, we have like 3 networks. This one here is just a way maybe to make things a bit complex. Okay, but this LAN here, the switch could have still get connection from this one. Okay, could have still be connected to this router 100 here. Okay, rather than this one. This one could have been kept away. Okay, but like it's just an extension. But mind you, here we have 6.0, which is also 30/30. I mean, which means 255 outside of side of 30 with subnet marks of 255.255.252. Okay, so that's it. And the same thing that happens with all this one, the zero. These are zero network. Okay, between this and this, and one network between these and three, and two network between this. So all of these areas here. Okay, this one. Okay, let me say from here right to this one. Okay, they are all side of 30. Okay, they are all slash 30, which means a subnet marks of 255.255.255.252. Okay, and what I did, because we have n devices and we can connect here as many devices as we want in real world, so therefore we can connect up to 254 devices to this switch. Okay, that one, like this one, is made a class 24 with 255.255.255.0. okay, and all of the LAN, okay, the interfaces that connect to the LAN network. That is what I did. Okay, so you can see here 192.168.11.0/24. okay, where 11.1 will be the I made the router interface, okay, that connect to the switch to be the 11.1. That's the first IP address is assigned to that interface. Okay, it's the same thing with this 13.0 network. Okay, the 13.1 is the interface that connects to the switch, and here again the 10.0, 10.1 is connected to the switch. Okay, and the same thing to here. Okay, and here also I made DHCP configuration. Okay, that's what I did to everything here. So we're going to do this one together, and it's gonna be on a series of videos as well. Okay, I'm gonna make a series of them. Okay, probably in 3 series. The first one now is this one I'm ending, okay, by showing you how this topology looks like, and the next one is for me to create this one same topology with packet tracer 5.3.1. okay, 5.3.1. okay, then after doing the interconnection, then I'll come to the configuration aspect of it with another video. Okay, the interconnection, the adding of devices and interconnection, all that will take us one video. Then doing the configuration, again, gonna be another video. So probably this one is going to take about 3 to 4 videos, okay, to complete the whole process. So I hope this one so far is informative, and I wish you the best. Please come and let's continue with the next tutorial. Thank you so much.